Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, we are now going to begin chapter 6, which is going to take us in a different direction than we've been in the previous 5 chapters. For the most part, we've been focusing on algebraic strategies and concepts. And in chapter 6, we're going to focus on transformations. And in this particular section, specifically rigid transformations. Um, and it's going to kind of tie in a little bit with algebra. It's not going to be straight geometry, but it's definitely going to be more geometry than algebra here, okay? So first thing we need to do is focus on what do we mean by rigid transformations. So a rigid transformation refers to the movement of an object or an image in a way that does not change the size or shape of the object or image. That's what makes it rigid, okay? We will get to some other transformations where the size does change, and that will not be considered a rigid transformation. It'll just be considered a transformation. But we're going to learn 3 basic transformations today, and we're going to work with these transformations for the first 4 lessons of this chapter. And so our first chapter test is only going to be focusing on rigid transformations. And then the second one that we'll get to after the holidays will be a different type of transformations, which we'll go in a lot deeper with. Okay, so let's read the introduction, and then I'm going to give you the 3 different types of transformations that we're going to be working with today and for this part of the chapter. So how can you describe the movement of a figure on a flat surface when it is moving in a straight line? For example, when you need to move a loose puzzle piece into the puzzle as shown at the right, how can you describe the way that its position changes? Today you will explore mathematical ways of sliding, turning, and flipping an object. Okay, I'm going to highlight those. You got sliding, turning, and flipping an object without changing its size or shape. These types of movements are what we refer to as rigid transformations, okay? When you don't change the size or shape, it's rigid. It stays the same. You will solve challenge problems as you explore transformations in today's lesson. So here are the 3 types of transformations that I want you to write in your journal. And if you get these nice and neatly written in your journal today, then when the M&Ms pop up for rigid transformations in a few lessons, you'll already have everything in your journal, so you probably won't have to record too much of anything else. So let's start with the translation. This symbol is a symbol that you're going to see when we use the online CPM tool for doing rigid transformations. This symbol means to translate, and a translate is also referred to as, let me do this in green, as a slide. And you'll see why we call this a slide in a second. So a translation slides an object horizontally and vertically, or both. Okay, so horizontally means it's going to go from left to right, side to side. Vertically means it's going to go up or down. And so let's say you want to get this particular triangle to have, let's see, what do you got? The orange, the green, and the red dot. So let me put the green dot, say we want to move the green dot so that it goes right here, okay? So all you have to do is focus on the green dot. How many units does it need to move to the left? It needs to move 1, 2, 3, 4 to the left. And how many units does it need to move up? It only needs to move 1 up. So if we slide this guy over, we'll first move it horizontally, and then we'll move it vertically. And that is referred to as a translation. We're sliding it in either a horizontal, a vertical, or both. In this case, it was both. Now, we don't want to move it diagonally. That's not going to work for this particular process. We've got to move at right angles, okay? So once you got it to here, then it can move at a right angle to go up vertically. So how would we describe that movement? There are 2 ways that we can describe the movement. One of them is to use the literal movement, where you could say it moved 4 4 units left, and then 1 unit up. That's one way to do it. Or we can use what is, oh shoot, what is it called? I can't remember exactly. It's some sort of notation. There's a name for it, but you don't need to know the name. It's totally okay. Coordinate notation, that's what it is. Coordinate notation where the x value, remember in a coordinate grid, the x value is the horizontal line that goes from left to right. Well, the x value of this point, in fact of all 3 points, went to the left 4 units, so that would be x minus 4, and the y value went up 1, which would be like y plus 1. When we do, that's not a g, that's y, by the way. When we do the online tool, this is how it's going to be shown. So it's good to think in these terms and record using the coordinate notation, okay? But this is definitely the coordinate notation that corresponds to slides, okay? And I'll model that for you, and you'll actually see it. When we use the online tool, they'll actually provide this for you, and then you can just copy it down. Okay, then there's the rotation, which also is known as a turn. So when you've got a rotation or a turn, the rotation turns an object about a point. To rotate an object, you must choose a point. That would be the rotation point. The direction it's going to go, that would be either clockwise or counterclockwise, and the angle of the rotation, which actually, the angle would be the number of degrees that it would rotate. Okay, and so this is pretty straightforward. How we would do this? So let's say I wanted to take this object here and I wanted to rotate it 90 degrees counterclockwise. So every one of the points, the orange one and the red one, are going to rotate and move 90 degrees, and this is going to be the point that's going to rotate over. Unfortunately, I can't show that too easily, so I'm just going to do that like this. Okay, so that is considered a rotation of 90 degrees. So we would maybe record this as 90. Oops, let me change the color there. Sorry. It's my OCD. I want to have everything, of course. Okay, there we go. 90 degrees counterclockwise. We can just abbreviate it. And then whatever the point is an XY coordinate. And because I don't have anything labeled there, the point would be the green point, but it would have a location on a coordinate grid, and we would record what that rotation point is. Okay, so that's incredibly important for when we are moving objects around, is make sure when you rotate it, you've got 3 different points you can rotate it on. You've got to make sure that you identify which point is the pivot point, and the other points move that number of degrees. And then our last translation is called a reflection. A reflection, sometimes you think of it as a flip. And the definition of reflection is the reflection flips an object across a line, which is called the line of reflection, right? To reflect an object, you must choose a line of reflection. So that's another piece that's really important, and the online tool is going to help you with that. And so if this was the original here, and you wanted to reflect it, this vertical line could be x is equal to 2 or x is equal to 0. And so I will show you how to identify what that line of reflection is, okay? But you just basically do say like, oh, night, dirt, 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 blue, color coordinated. So you would say across, we always reflect across a line, and in this case, the vertical lines pass through the x-axis, so these lines are defined by whatever point on the x-axis it goes through. And so that might be, over x is equal to 0. If this was a coordinate grid and x, this point right there was where x was equal to 0, that would be the y-axis. It would flip over the y-axis. Okay, so let's get to it. Here are all of those symbols. What we're going to do is we're going to go to our online book. 6.1.1, rigid transformations. This is puzzle number 1, the key in the lock puzzles. Now, resource page, I'm not crazy about the resource page, but I've used that resource page to create my own document that you're going to record these moves on, okay? And you can find this document on the Google Classroom. It's a Word document, and you can just print it off. Actually, you know what I should do is I should probably make this into a Google document, and then you can type everything. That's what I'm going to do. So you won't have to print this one off. I can just as easily create a Google document. Okay, so I'm thinking out loud right now, but this is going to be attached to Google Classroom as a Google document. Although, will you be able, oh, I guess you're going to have to make a copy of it. You'll have to make a copy of it and then make it your own file in your own Google Cloud. That's what you will do. Tell you what, I'm going to do both. I'm going to put the Google document and I'm going to put the Word document so that if your preference is to just print it off and write on it, you can do that, or you can make a copy of it and then type everything into the record sheet. Okay, so now that I've got that all worked out in my head, this is what we need to do. We're going to go here, we'll scroll down and don't use that, and then we're going to go through and do these different puzzles. And this is what the puzzle looks like. In fact, let's see here on the document, we have intro number 1. We're going to do this together, and this is how you record your moves. This is how you record the details, okay? And the name of the puzzle is listed on the left. So we're going to choose intro number 1. And what you've got is a key, and here is the lock, okay? So it says start at 4, 2. So that's how you know that this is the starting point here, because that circle right there where it's going to be the pivot point is going to be where x is equal to 4 and y is equal to 2, okay? So that's the starting point, and what you need to do is choose a series of moves. Now, I'm going to tell you right now, it should never take you more than 3 moves to get through these puzzles. If it takes you more than 3 moves, you could be more efficient, okay? Doesn't mean it's wrong if it takes you 4 moves. It could take you 5 or 6 if you really wanted to. But I've already done all of these puzzles, and each one of them can be done efficiently in 2 moves or 3 moves. I don't know that any of them can be done in 1 move, though, but we'll see. Okay, so what I generally like to do is I like to orient the key in a way so that it'll be in the same position as our lock, okay? And so in order to do that, we would need to rotate this guy so the handle comes up here and the key, the prongs of the key face to the right. So to do that, I'm going to need to do a turn or a rotation. So I'm going to click this button here, which means to rotate. And now you've got a choice. You can rotate counterclockwise, or you can rotate clockwise. So CW means clockwise. That means it's going to go the direction of the clock. And CW means counterclockwise, which means it's going to go the opposite direction of the clock. 90 degrees would form a right angle, right? It'd 90 degrees. 180 degrees means it's going to go all the way to the other side. So it's better to just see the 90-degree turn? Okay. Now let's do it again, and now let's do 180 degrees counterclockwise. See how that went from here to here? That's a total of 180 degrees. In fact, you can kind of see how that's shows 180 degrees there. Now watch what happens if I go 180 degrees clockwise. Notice how it goes to the same position as it was in before. So 180 degrees clockwise, really pushing the same spot as 180 degrees counterclockwise. But the 90-degree turns, if you go 90 degrees clockwise, it's going to go, the handle is going to go down because the pivot point is at 4-2, and that's where the key prong part is attached. Okay, so that's not oriented correctly. The correct orientation was when I rotated it 90 degrees counterclockwise across, or pivoting on point 4-2. So I'm going to do that, and then I'm going to go to my record sheet. Oh, I didn't do that as my first. Oh, well, I did it in a different order, but that's totally okay to do it this way. And then once it's reoriented, then we need to slide it into place. Basically, your flips and your rotations get your key in the right, going in the right direction, and then your slide will move it into place. That's typically how I like to have students do it. and I have no idea why I did it in a different order here, but I'm going to do it again in this order and prove to you that this would work, okay? So there are literally an infinite number of ways that you can get this key in there. There isn't one right answer. You just need to get it in there, and there's this really neat thing that a key lock puzzle does to tell you that you were successful, and I'll show you right now. Excuse me. So to get this into place, we always do, this is going to be the slide button, so we're going to click the slide, and the way that this program works, and it's sort of a pain, but it's just something you have to work with, is it always moves in the X direction first, no matter what. So let's go ahead and do that. We got to go 1, 2, 3, 4, 5, 6 units to, no, 7 units to the left, right? We need to get this to where X is equal to -3, and right there it's at +4. So it's going to take 7 units to the left. 1, 2, 3, 4, 5, 6, 7 units to the left, which is X -7. And then that would bring us to here. And then how many units does it need to go down? It needs to go from 2 to -4. So I think that's going to go down 6. 1, 2, 3, 4, 5, 6. Yes, 1, 2, 3, 4, 5, 6. And when we click that, then it puts it into place. And this is how you know you've got it right. So once you know it says congratulations, then you just come over here and you identify what was the move and what was the specifics, the details. Now, this does not tell you the pivot point for the rotation, but it will tell you the coordinate notation. And if you had done a flip, it would tell you what line you were flipping over, okay? So that absolutely works. Now, let me actually use, let me start this guy over. Let me actually use this here. Here it said that we went from -7 and the y, x -7 and y -6 was my first move. So let's do that first. Y or x -7, y -6. And now our pivot point is where x is equal to -3 and y is equal to -4. So that's why I have that right there. So now we'll do the rotation second. And that was 90 degrees. Actually, you know what I'm going to do this time? What if I do 270 degrees clockwise? Watch what happens. Whoop, that works too. Okay, so that's cheating because that's not exactly what I said I was going to do. So let's go ahead and do 90 degrees, and there it is. Okay, so that is how this works. We make sure that we identify what is the move, and then use the notation that is provided in the online tool to record the details. All right, now the next one we're going to do is intro puzzle number 2. After we do intro puzzle number 2, I'm going to let you go ahead and do the rest of them. And I could show you the answers to each one of those, but you might you might actually have the right answer, but you go in different directions than me. So I'll just show you all my answers, and you can pause it. You can compare yours to mine at the end. I am going to let you work on this independently and just play around, and then you'll be able to pause the video on what my answers show. So that'll be like the model for the way that you set every one of these up, knowing hopefully that maybe you've got different answers than mine that work just as well. All right, so let's go to intro puzzle number 2. So for intro puzzle number 2, what I always try and do first is reorient this key so that it's facing the same way as this one. Now, there are a couple of ways to do it. One of them would be to start with the rotation. Another way would be to do some kind of a flip, okay? So I think, actually, now that I think about this, I did this in 3 moves, but I think it can be done in 2 moves. I think we could flip this guy over any one of these vertical lines. So let's do a flip, and if I go here, it's going to flip over one of the horizontal lines. You see how those two guys are showing a reflection over a horizontal line? We need to do this kind. We need to flip over one of the lines that is defined by x is equal to a number. So you want to flip over x is equal to 1, over x is equal to 2, over x is equal to 3. It literally makes no difference what we flip over. So I'm going to say, let's flip it over x is equal to 1 and watch what happens. Okay, so we would want to record that, flip across x equals 1. And now I'm going to move it 1 unit to the right and 1, 2, 3, 4 units down. So that's a slide, 1 unit to the right and 4 units down, and that's going to put us into place. And so you would just record flip across x equals 1, slide of x plus 1 and y minus 4. Now, let me look at this one because it occurs to me that I did 3 of them. I started with a turn or a rotation of 180 degrees counterclockwise over 0.12. So let's go ahead and do this again. Get out of there. So I rotated it 180 degrees counterclockwise, and there's 0.12, right? Our starting point. So I did that first, and then what did I do next? Then I flipped it across where y was equal to 0. So here's where y is equal to 0, right? Right there. So it's going to be this horizontal line. So I'm going to do a flip over a y line, and where y is equal to 0, I'll just hit the check button, and there it goes. And now my last move will just be to move it 1 unit to the right. And so x is going to increase by 1, but y won't change at all. So look at how I note that. X increases by 1, that moves 1 unit to the right, but y isn't changing at all, so it's not going up or down. So you want to include both of them, exactly how it shows here. Okay, so that works. That was a success. It could be done in 2 moves. It could be done in 3 moves. You could slide it all over the place if you want to do 20 different moves until eventually you get it where you want it. But that's a terrible waste of time. Okay, so this is what I would like for you to do. I would like for you to pause the video and go and do the remainder of these puzzles. And I'm going to suggest that we do wall number 2. And this one, I would give students a choice. Just do wall number 3. This one, do star number 1, star number 2, and challenge number 1. Okay? Take your time on those. Have a little bit of fun. In fact, you know what? I'm going to do one more for you. So that was this one. I'm going to do wall number 1 as well, because this guy gets a little bit tricky with walls. So wall number 1, there we go. All right, so here's a problem with walls. You can't go through them. You've got to go around them. And this particular one is kind of set up so that you have to go right or left first. You can't go down. It's not going to let you do that, okay? Can't do it. So we would probably want to move this guy over to the right and then do a flip to reorient it and then move it into place. Okay, so we'll start by sliding this guy. How many does this key need to move? 1, 2, 3, 4, 5, 6, 7. It's got to move 7 units to the right. Watch what happens when I only move it 6 to the right and then try and go down. It won't let you. You got to go at least 7 to the right before it can go down. So let's try this again. 1, 2, 3, 4, 5, 6, 7. And then, I don't know, we could just say why, let's just do that. Let's just move it to the right. Okay, so there we go. Now we might want to reflect it. And so what do I want to reflect this over? I could reflect it over y is equal to 3, y is equal to 2, y is equal to 1, y is equal to 0. You can literally reflect it over anything you want. It's not going to make any difference as long as you reflect it over a y line, not an x line. Okay, so remember, the y lines are the horizontal lines that pass through a given number on the y-axis. So right now, this is on y is equal to 4. So if I choose to reflect that over y is equal to 4, it's going to reflect like that. If I choose to reflect it over y is equal to 2, it's going to go like this. However many units it takes to get to y is equal to 2, it's going to go the same number of units past it. That's the key to all reflections. The line of reflection, however many units it takes you to get to that line of reflection, it's going to reflect on the other side the same number of units. So I chose to reflect over y was equal to 2, and now that I've got it in place, now I can just slide it down. Now someone might be saying, hey, what if we would have reflected over y is equal to 1.5? That would have actually gotten us into play. The problem is we're limited by our computer. There's no option for fractional lines in this particular tool. So we have to use whole numbers or integers and then slide it the rest of the way. So I'm just curious. We started with moving right 7 units. Then I flipped it over y was equal to 2. So it looks like the last thing I need to do is just move it down 1 unit. So that's a slide where x doesn't go right or left, but y goes down by 1. So this is going down 1 unit, and that's it. There you go. All right, so go ahead and pause the video. Go ahead and play around with this, and then when you unpause it, I will reveal all the other answers that I came up with, but you need to know that for the remaining puzzles, you might have a different set of instructions than what I have, because you could do it in a number of different ways. And as long as you get the congratulations and you copy down what we've got here, you've done it correctly, okay? So just be careful. When you have a rotation, please make sure that you show your pivot point, what it's pivoting over as a part of your detail. Okay, so go ahead and get to work, and when you're ready to look at my answers for the remaining puzzles, you can pause and check and see how yours compare to mine. Or if you just feel really confident, you know what's going on, you can stop the video now and just go ahead and play around with these key lock puzzles and record everything. Now, when you take an assessment, when you take a chapter test, you're going to have to do the recording. I don't know how I'm going to work that out on the Google Forms, but that is an important part of this particular chapter, is being able to write in the details of this. And so, yeah, we'll work that out. Okay, I'm going to pause now. Have you paused yet? Because I'm ready to do the reveals. And so you don't want to cheat. You don't want to see the answers. That takes the fun out of it. So if you haven't paused yet, please pause. I'm going to go ahead and do the reveal now in 3, 2, 1. All right, wall number 2. You can get where you need to go by rotating or turning your key 90 degrees counterclockwise over point -1, 1. A series of slides. Slide to the left, or slide down 5 units, and then slide it again 5 units to the right and 2 units up. That will get your key into the right location. For wall puzzle number 3, I started with a 180-degree counterclockwise turn over point -2, -1. Then I slid it down 2 units, and then my last slide went 5 units to the right and 7 units up, and that got our key where it needed to be. For star puzzle number 1, I started with a, was that supposed to be counterclockwise? That's not supposed to say CCC. I think it's CCW. Oh, I can't take that. Hold on. I'm going to pause. Okay, much better. So it started off with a 90-degree counterclockwise turn over point -5, -3. And actually, I think sometimes they say about point, like, I don't know if you're really going over something or you're going around, or the pivot point is definitely this. I'm not sure what the best word to use for that, but I'm just saying over this point. And then you flip it over x is equal to -1. And this is one where you could have chosen a lot of different lines to flip it over. But I just chose x is equal to -1, but you could have done any number of lines that were x lines. And then your slide, depending on what you flipped over, your slide would change, okay? So since I flipped over x equals -1, that landed me 1 unit to the right of my target. So I had to go left 1 and then down 5. So depending on what your reflection line was, you may have chosen a different last move for your slide. Let me get this guy out of the way. Okay, and then star number 2 started with the turn again, counterclockwise, 90 degrees over point -3, -4, and then I slid it left 6 units and up 6 units, and then flipped it across y is equal to 2 to get it into place. Now, once again, depending on what you did here, you may flip it over a different line and still end up getting it to where you need to get it. Okay, but I was able to do it in 3 moves by doing this slide, 6 units to the left, 6 units up, and then just a flip over y equals 2 got me where I needed to be. And then the last one, the challenge puzzle. This is the challenge puzzles. For some reason, they put in right triangles instead of keys. Not quite sure why they do that, although I think in a later lesson, when we have to do the charting on the coordinate grid with the key movement, it's easier to do it if you're picturing it as a triangle rather than a key. So that's probably why they do this. But it started off with a slide where I had to move 6 units down. And I think the reason why I had moved 6 units down and I didn't want to move left or right is because I was going to run through a wall. So I couldn't go to the left or to the right. So I just went 6 units down, then 180 degrees. And this time I chose to go clockwise instead of counterclockwise over 0.5 -2. And then once I got the key oriented the way we wanted it, then I went to the left 10 units, and that put it into place. Okay? All right, so this is an introduction to the world of rigid transformations. I hope you enjoyed working with the key lock puzzles, and we're going to continue for the next 3 units kind of talking about these different types of transformations and kind of putting them, I think, into a real world kind of a context. Maybe, sort of, kind of. Okay, talk to you later. Bye.
Hey, feeling good, like I should. When in dark, walk